In today's short video, we will learn about electro-discharge machining. First of all, as the name suggests, it is a non-traditional machining process. Non-traditional machining processes can be classified into four types: mechanical, electrochemical, electrothermal, and chemical. Electro-discharge machining is a type of electrothermal machining process. That is, it uses electrical energy to create heat, which is then used to remove material. Now, let's look at a schematic of an electro-discharge machining process. As you can see, it consists of the workpiece placed in a dielectric tank. A tool is in close proximity to the workpiece. The workpiece sits on a fixture. The tool and workpiece are connected to a DC pulse generator. A pump is in place to continuously renew the dielectric in the system. Electro-discharge machining carries out erosion of material with the help of electric sparks. Now, to understand how EDM removes material, let's examine a single spark in the erosion process. As a pulse of DC electricity reaches a part, an intense electric field develops in the gap. Microscopic contaminants suspended in the dielectric fluid are attracted by the field and concentrated at the field's strongest point. These contaminants build a high conductivity bridge across the gap. As the field's voltage increases, this material in the conductivity bridge heats up. Some pieces ionize to form a spark channel between the electrode and the workpiece. At this point, both the temperature and pressure in the channel rapidly increase, generating a spark. A small amount of material melts and vaporizes from the electrode and the workpiece at the points of spark contact. A bubble composed of gaseous byproducts of vaporization rapidly expands outwards from the spark channel. Once the pulse ends, the sparking and heating action stops, collapsing the spark channel. Dielectric fluid then rushes into the gap, flushing molten material from both surfaces. This EDM residue consists of small solidified balls of materials and gas bubbles. Now, the resulting EDM part can have several observable surface layers. The top surface layer is created when expelled molten material and small amounts of electrode material form spheres and spatter the surface. This layer is easily removed. The next layer is a recast or white layer where EDMing has altered the workpiece metallurgical structure. This layer can be reduced by using the right control settings or by polishing the part. The third layer is a heat affected zone or annealed layer. It has only been heated, not melted. Now let's look at two different types of EDM systems. One of them is the RAM EDM. In RAM EDM, the workpiece mounts inside a tank and is covered with a dielectric fluid. An electrode then lowers to within a few thousandths of an inch of the workpiece to begin EDMing. RAM type EDMs have the ability to produce complex cavities out of solid piece of metal. RAM EDM machines are also referred to as die sinking or vertical EDM and range in size from automation from manually operated tabletop systems to large bed manual or computer numeric control systems. RAM EDM has four major subsystems: a power supply, a dielectric system, an electrode, and a servo system. On the other hand, CNC wire cut EDM machines use a traveling wire electrode to cut complex outlines and fine details in stamping and blanking dies or pre-hardened tool steel. The wire drive system continuously delivers fresh wire under constant tension to the work area, guided by a set of sapphire or diamond wire guides. New wire is always exposed to parts, so electrode wear is not a problem in EDMing. Wire EDMs are also easier to run than RAM EDM systems. They can run unattended for long periods, including overnight and weekends.